shows the hepatopancreatic ampulla. It's the only one that shows it. This space here. The space here. Right? All the white. The black. Cavity. Dental caries. These little tubules. Dentin. Where the enamel stops, what becomes the surface material of the tooth? Cementum. What attaches the cementum of the tooth to the bone? Periodontal ligaments. All the pink. Pulp. And little inflammation there. And pulp has nerves and blood vessels, but does not have lymphatics. I'll get on it, yeah. Eventually I'll fill that in. So all of these models go together. It's a set of 8. And the first thing I would look at is the tops of them. So this one you see villi. This one, no villi. This one's nice and flat. Definitely no villi. Kind of bumpy, but still relatively flat here as well. So the one with villi must be small intestine. Then you got to figure out what part of the small intestine. There's a few things you could look for. You might just go straight to the bottom of the model. Look for that outermost tunic. I don't see a simple squamous epithelium here. I only see connective tissue at the bottom. So that means the outermost tunic is adventitia. What part of the small intestine has adventitia? Only the duodenum. There's a second thing that the duodenum and only the duodenum has, which you can see. There's lots of them here. Submucosal glands, called duodenal glands, all of the green. What are the white cells here? Goblet cells. All the other cells? Absorptive cells. Now when you get way down here into the mucosal glands, you're going to find some other cell types like enteroendocrine cells, Paneth cells. And what do we call these mucosal glands down here? Intestinal glands or intestinal crypts. Okay. So we look at the top of this one, like the other villi. So we know small intestine. Try to figure out what part. You look at the bottom, there is a simple squamous epithelium. So there is a serosa, it's not duodenum. What would you find in the ileum that is less, what would you find in the jejunum that is more abundant than in the ileum? Way more plicae circularis. But we can't rely on that for this model because we can't see plicae at all. So instead we have to look for something that you do find in abundance in the ileum that you don't see as much of in the jejunum, and that is Peyer's patches. Big groups, big clusters of follicles. So I think we can probably assume this is ileum. That's probably what they're trying to show here with this big follicle. So we've got villi again, but then we've also have this flat surface. So I guess potentially it could be transition from small intestine to large, or it could be from stomach to small intestine. So probably the best thing to do is to look at this side, because we already know this is small intestine. We want to know, is this stomach or is it colon? Because from the top, it doesn't look all that different. They're both relatively flat, no villi. So the first thing you should notice here is this huge, thick layer of circular smooth muscle. Would you find that at the transition or the junction between small intestine and stomach, or small intestine and large intestine? The pyloric sphincter. is by far the most effective sphincter, has the thickest layer of circular smooth muscle. And this is super thick. So that's where we are here. We're at the pyloric sphincter. And the other thing we can look for to figure that out, if this was large intestine, then this would have to be ileum. Ileum doesn't have submucosal glands. Duodenum does. So it must be stomach to duodenum. And that's what it is. Serosa at the bottom. Right. So the serosa, at some point after leaving the stomach and moving on to the duodenum, is going to disappear. We're at the junction. It hasn't disappeared yet. So don't let the presence of serosa convince you that this can't be duodenum. We just haven't gotten far enough along. It will disappear. Flat surface, no villi, so it's not small intestine.
Stomach.
The epithelium is simple columnar, so it's not esophagus. Maybe stomach, maybe colon. What could we use to differentiate?
3 layers.
1, 2, 3. There's your 3 layers. It's got to be stomach. Which means all of these mucosal glands are called gastric glands. There's holes that lead into those gastric glands, and those little holes are called gastric pits. The cells that form the surface epithelium also reach down and line the pits, and those are called mucus cells, surface epithelial cells. How are those different from the mucous neck cells that are a little further down? And kind of blending them together here. They secrete an acidic mucus, whereas the surface epithelial cells secrete an alkaline mucus. They're not really distinguishing between the two, though. And then when you get into the glands, in addition to mucus cells, you also have chief, parietal, and enteroendocrine cells, G cells in particular. So it's hard to tell what's enteroendocrine and what's chief, because they only give us 2 really distinct cells. But these really big red ones, parietal cells, definitely. Parietal cells are quite large. But other than that, it's a mixture of G cells and chief cells. We can't tell from the models what's what. This little round thing here, it's a little moon.
What is it?
Here's a big moon.
Is it malt?
Here's a little
Lymphatic
moon.
follicle.
It's a lymphoid follicle or lymphatic follicle. Yeah, it's just not very big. But you find them throughout the entire gut. So yeah, it's part of GALT or MALT. Flat, has serosa, only 2 layers of muscularis externa, can't be stomach, no villi, can't be small intestine. Simple columnar epithelium, can't be esophagus, colon, large intestine. The white cells, goblet. There should be, by the way, and there isn't, but there should be way more goblet cells on this model than the small intestine. That is a difference between large and small. Large has way more goblet cells. These models show about equal numbers of both. Similar, thinner wall, bigger follicle, otherwise pretty similar. This is a modification of this. This is an outpocketing of this.
Appendix?
This is appendix. So the histology is very similar to the rest of the colon, except the wall is thin, and most of the submucosa is taken up by follicles, huge aggregates of follicles. So this is appendix. Stratified squamous, flat, must be esophagus. Little adipose here. Adventitia at the bottom, no serosa. Submucosal glands with a duct to get the secretion to the surface, What are these submucosal glands called? Esophageal glands. What do they secrete? Lots of mucus. So we've got a little bit of that, and then we've got a little bit of this. So this is the transition from pharynx to esophagus, or esophagus to stomach. So we're at the transition. We don't quite yet have all three layers of externa, so just a circular and longitudinal. So don't let the fact that there's not three there make you think that this can't be stomach. We're just transitioning into the stomach. So we are beginning to see some gastric glands. And you're seeing the submucosal glands disappear. Right? There are no submucosal glands in the stomach. What would you call the junction between the esophagus and stomach?
Cardiac sphincter.
And what is right there at that juncture? Cardiac sphincter. Yeah. And you do have a relatively thick layer of circular smooth muscle, just not as thick as the pyloric sphincter. This model is showing 4 regions in one model, but there are issues with it. What's the top here with the submucosal gland? It's got a duct going to the surface, esophagus. You can also see the stratified squamous epithelium. And then it goes to simple columnar here, here, and here. Here, those bumps are villi, so this must be, right? So you have esophagus, small intestine. So this should be, those are gastric pits, gastric glands. The problem is I only see 2 layers of muscularis externa. The muscularis externa here looks the same as it is there and there. So, mistake. There should be 3. And if this is small, then what's this? Large. At least they show more mucosal glands. That's good. What are these purple things here? Yeah, lymphatic follicles. And then as far as the outermost tunic, serosa, serosa, serosa. But here, you're missing that epithelium, so this is adventitia. As it should be. That's esophagus. And then they do a little microscopic anatomy on the backside here. So this gland is a submucosal or esophageal gland. This gland, gastric gland, it's a mucosal gland. These red ones should be the parietal cells. This one, it's the luminal membrane. That should be a chief cell because the vesicles are at the luminal membrane. If the vesicles were at the basolateral membrane, then it should be an endocrine cell, yeah, an enteroendocrine cell or a G cell, because the hormone's going to go across the basolateral, not across the luminal. And this gland here, intestinal gland or intestinal crypt. I wonder if this is a Paneth cell. Not really sure. And then same thing down here. Intestinal gland, mucosal glands, intestinal crypts. But since this is large intestine, more goblet cells. Oh, that's what these red ones are. So up here it's parietal, but these ones down here, these are goblet, and they did put more in the large intestine, so that's good. That's definitely the case. How about this area where everything's entering and exiting the liver? It's not hilum or hilus, but it kind of means the same thing for the liver. The port of the liver. Porta hepatis or porta hepatis. Okay.